how to solve problems in cylinders, especially when it connected with a lever system. Typically, cylinders have levers in the system, so you're always it's not just a single cylinder. It has some kind of levers connected to it. So think about this example. So if you have a car floor jack, which is used to lift let's say 3-ton floor jack, which is used to lift a big weight. So the way it is designed, it has a pivot point here, and then there is this one. So the way it works, this cylinder pushes this way, and this is a solid piece. So when this extend out, then this is start to go up. So this is where you have the car. Whatever that thing is. So the car, if you have like this, so this is the car. Very nice drawing. So this is pivoted here, and then the cylinder when you push liquid in there, and the cylinder kind of extend out. When it extend out, because this is a solid piece, this is also a solid piece, so it's kind of rotate with respect to the pivot this way, and then the car goes up, so it's lifting the load like that. Now it is very difficult to figure out whether it's a second class, first class, third class lever. And when you solve problem, do not try to figure that out. All you are worrying about how to design a 3-ton floor jack, for example. So all you need to do, just only way you can solve cylinder problem is to take moments with respect to the pivot point. Take moments with respect to the pivot point, and then you are done. There is another reason to take moment with respect to the pivot point, because the force acting on this pivot point constantly changing the direction. We don't know whether it acts this way or this way or this way. So if we don't take moment with respect to that point, we won't be able to cancel that force. And we're not really interested in what force acting in there. All we are interested in how much force this cylinder need to develop, and then how much load we can lift. So that's all we are concerned about in this problem. Now, how do you take moments? So there are two ways you can work on moments. If I redraw, it's kind of messy already there. So we just redraw it as W, and then you got a force here, and you're taking moment with respect to this point. Now, moment is the definition of moment is the force times the perpendicular distance or shortest distance. Now, you can do that. So just calculate the distance, shortest distance. In this case, this is my shortest distance. So if this is at an angle theta, and we know this is a solid piece, we know this distance. So let's say this is L. So we can say L cosine theta. So the moment for the W would be W times L cosine theta. So that's one way by the definition of the moment. Another way we can resolve this force to the perpendicular direction. Then the perpendicular part is the shortest distance. So, and then another component we can resolve this way. So we could do something like this. This would be W sine so this is then theta. Sorry, that's going to be W cosine theta. And this would be W sine theta. So if we take moment by this, after resolving the force, it's going to be moment equal to the force, which is W cosine theta now, times the length, shortest distance, which is L now. So as you can see, it's the same thing. So here, without resolving it, it was something like weight times L cosine theta. You end up with the same thing. So whatever makes easy for you, just do that. Either you take the shortest distance or resolve the force. So to summarize, to work with the cylinder problem, you take the moments with respect to the pivot point, and then either you resolve the forces or you just find the shortest distance, and then all moments, summation of all moments, sum to 0, and you're done.